Hello everyone, and welcome to Earth Archives. Today's star of the show is truly a superstar in the universe. Without it, we simply couldn't survive. That is, the sun.
The sun, that giant burning fireball hanging in the sky every day, is the fundamental reason life exists on Earth. It continuously provides light and heat, warming our planet, allowing all living things to grow, seasons to change, and serving as the most important energy source in nature. However, many people might not know that the sun is not just a random glowing ball. It is a star with a specific classification, a yellow dwarf, scientifically known as a G-type main sequence star. In the vast universe, there are many kinds of stars, ranging from enormous blue giants to tiny red dwarfs. The sun belongs to the medium-sized G-type main sequence stars, not particularly huge nor small, but a middle-of-the-road type in stellar classification. Its surface temperature is about 5,500 degrees Celsius, which causes it to emit a warm yellow light, perfectly illuminating our sky. At the sun's core, nuclear fusion reactions convert hydrogen into helium, releasing immense energy. This energy takes tens of thousands of years to slowly travel to the surface, eventually radiating into space as light and heat. This process makes the sun a stable and long-lasting energy source, maintaining Earth's ecosystems and climate balance.
Middle of the road? I don't buy it. I have to put on sunscreen and wear sunglasses every day under the sun. It's so powerful. How could it be just an ordinary character?
Haha, I get what you mean. The sun looks so dazzling and lights up our sky every day, but compared to the vast, endless universe, it's actually just an ordinary person. Think about it. Some blue giants are thousands of times brighter than the sun. Their starshine, so intense they're like the superstars of the cosmos. On the other end, red dwarfs live for hundreds of billions of years, like the eternal evergreens of the universe, quietly guarding their little corners. Compared to those, the sun is like a middle-aged guy, not chasing flashy brilliance, nor having an extraordinary lifespan. But it's someone you can fully rely on. It's warm and stable, continuously providing light and heat to Earth for billions of years, allowing life to thrive. This kind of stability is extremely precious in the universe because stars that are too intense tend to explode violently, causing destruction to their surroundings. Red dwarfs last a long time, but don't produce enough energy to support the flourishing of complex life like on Earth.
Oh, so it's not the wildest superstar, but rather the most reliable neighbor?
The sun's existence is truly a rare, just right in the universe. Its size, brightness, and lifespan perfectly create an environment suitable for the birth and flourishing of life on Earth. Imagine if our star were a blue giant. What would that be like? Although blue giants shine brilliantly and emit intense heat, their lifespans are surprisingly short, often only a few million years before burning out. Such a brief life cycle simply wouldn't give life enough time to evolve. Organisms on Earth wouldn't have the chance to embark on a long evolutionary journey. On the other hand, if our star were a red dwarf, it would live for hundreds of billions of years, making it one of the longest living stars in the universe. But the light and heat it emits are far less than the sun's, causing the planet's surface temperature to be as cold as a freezer, making it impossible to sustain liquid water. The energy and conditions necessary for life would be lacking, and Earth might remain a frozen wasteland where life could hardly arise or continue. The sun, a medium-sized yellow dwarf, strikes the perfect balance between brightness and lifespan. It has enough energy to maintain Earth's suitable temperature, allowing water to stay liquid, and boasts a stable burning period of about 10 billion years, providing ample time for life to evolve. Because of this, life on Earth was able to progress from simple single-celled organisms to a complex and diverse ecosystem.
So how was the sun born? Was it shining so brightly right from the start?
Of course not. The sun's birth was like a grand epic, full of drama and magnificent cosmic wonders. About 4.6 billion years ago, A huge cloud of gas and dust floated in the vast universe. This is called the solar nebula. This nebula was mainly made of hydrogen gas mixed with small amounts of heavier elements, precious materials scattered throughout space by previous stars that exploded. Over time, this enormous nebula began to collapse under its own gravity. The gas and dust particles drew closer together, increasing in density and forming a core that gradually heated up. This process was like a slow but intense cosmic gathering, where countless tiny particles and gas molecules attracted each other and merged to form larger and larger bodies. As the core temperature soared to millions of degrees, hydrogen atoms began to fuse, releasing immense energy. This marked the sun's official entry into the main sequence stage. A true star was born. During this long process, the leftover gas and dust gradually formed a protoplanetary disk around the sun, where future planets, moons, asteroids, and comets slowly took shape.
Collapse? Does that mean the whole cloud is squeezing toward the center?
The sun's birth process is like a cosmic-level superhug. The gas and dust cloud, pulled by gravity, gets tighter and tighter. The force of the collapse is incredible. As this force compresses the entire nebula, the sun's core becomes denser and denser, and the temperature rises sharply. All these changes also cause the sun's rotation speed to increase, much like a figure skater spinning faster when pulling their arms in tight. This phenomenon is actually the cosmic law of conservation of angular momentum at work. When the huge nebula shrinks in size, to maintain rotational energy, its spin naturally speeds up. What was once a slowly rotating cloud gradually becomes a rapidly spinning young star. Material flows like a torrent into the core, creating immense gravitational pressure that raises the core temperature to millions of degrees and starts nuclear fusion. This process not only makes the sun steadily shine, but also affects the surrounding protoplanetary disk. The speeding up sun, like the core of a dancer, drives the surrounding gas and dust to spin in circles, slowly forming planets, moons, and other solar system bodies. What seems like a chaotic dust cloud transforms, through the harmony of gravity and rotation, into an orderly and vibrant cosmic system.
Wow, so the laws of physics work the same way in the universe. What happens next?
The sun's birth is a magnificent cosmic miracle, and the most crucial moment comes when the core's temperature and pressure keep rising until they reach a decisive tipping point. As gravity continues to compress the gas and dust in the sun's core, the temperature soars to about 15 million degrees Celsius, and the pressure becomes unimaginably high. In this extreme environment, hydrogen atoms no longer exist alone, but begin to fuse together to form heavier helium atoms. This process is called nuclear fusion, the ultimate source of energy in the universe. When hydrogen atoms fuse into helium, they release a huge amount of energy, radiating light and heat throughout every corner of the sun. It's like igniting a gigantic flame. The powerful energy radiates outward from a core, making the entire sun shine brilliantly, becoming the dazzling star we look up to every day. Nuclear fusion is not only the fundamental reason the sun emits light and heat, but it's also the cornerstone for life on Earth. It's this steady and continuous energy that warms our planet, keeps water in liquid form, and maintains an environment suitable for living organisms. Every time the dawn breaks and sunlight passes through the atmosphere to shine on the land, we are actually feeling the effects of this cosmic drama that has been unfolding for billions of years.
So the sun is basically a cosmic nuclear fusion reactor?
The sun performs an amazing daily energy conversion show. It fuses countless hydrogen atoms into helium atoms, releasing an astonishing amount of energy, roughly equivalent to the simultaneous explosion of 900 billion nuclear bombs. However, what's remarkable is that this massive energy release doesn't happen as a violent explosion, but continues in an extremely stable and balanced way, allowing the entire sun to shine steadily and persistently. This stability comes from the sun's intricate, self-regulating mechanism. When the core's nuclear fusion produces too much energy, the temperature and pressure rise, causing the sun to expand, which in turn lowers the core pressure and slows the fusion rate. Conversely, when energy production decreases, the sun contracts slightly, increasing the core pressure and speeding up fusion. In this way, the sun's energy output remains within a stable range, avoiding violent explosions or cooling down, like a precisely tuned engine running flawlessly. This stability not only ensures the steady operation of the solar system, but also makes the miracle of life on Earth possible. The just right continuous supply of energy keeps Earth's temperature suitable, water in liquid form, the climate moderate, and ecosystems thriving. It's because of the sun, a gentle giant, that we experience changing seasons, the cycle of day and night, and feel the warmth and light of the sun.
Sounds amazing. So how old is the sun now?
If we compare the sun's life to a human lifespan, it's currently in its prime, around 40 to 50 years old, full of energy and steadily developing in its golden years. The sun was born about 4.6 billion years ago and has gone through a long period of growth and evolution. Right now, it is in the main sequence phase, the most stable and longest-lasting stage in a star's life. This stable period will continue for another roughly 5 billion years, meaning the sun still has plenty of time to keep shining steadily, providing the essential light and heat to Earth and the entire solar system. From this perspective, we don't need to worry about the sun burning out or undergoing drastic changes anytime soon. Its vitality remains as strong as ever. During this phase, the sun's core continues to fuse hydrogen into helium in a stable manner, producing a continuous stream of energy. This is the driving force behind its ongoing brightness. Like a middle-aged person steadily moving forward, the sun's energy output is balanced and sustained, keeping Earth's environment relatively stable and allowing life to flourish.
Phew, that's a relief. Otherwise, I'd still be stressing over what to eat for dinner, but it'd be way worse if the Earth got frozen first.
Don't worry too much about the sun right now. The real uncertainty lies about 5 billion years from now. By then, the sun will enter its final life stage and start to expand dramatically, becoming a huge red giant. At that time, the sun will be like an irritable giant slowly swallowing the planets around it. In its red giant phase, the sun will swell to over 100 times its current size, so enormous it could engulf Mercury and Venus, and possibly Earth as well. Imagine the once warm and pleasant Earth being engulfed by the intense heat of this fiery giant, surface temperatures soaring, oceans evaporating, making life impossible to survive. This is an unavoidable cosmic rule. Stars have life cycles just like living beings, with youth, adulthood, and inevitable aging. As the sun's core hydrogen fuel gradually runs out and nuclear fusion weakens, the core will contract while the outer layers expand. This massive swelling signals the sun's farewell to its stable phase.
Wow! Sounds like a cosmic apocalypse movie.
Facing the harsh reality that the sun will one day become a red giant, swallowing Mercury, Venus, and even Earth, humanity should have already planned ahead and actively searched for a new home. After all, Earth's lifespan is limited. We can't just sit and wait for the end. We must embrace the spirit of exploration and expand our living space beyond our home planet. Moving to other planets or star systems is no longer a distant dream from science fiction. It's an inevitable trend driven by advances in science and technology. Whether it's Mars, the Moon, or even more distant exoplanets, any of these could become humanity's new home. This requires not only advanced space travel technologies, but also interdisciplinary collaboration to solve complex challenges like life support, energy supply, and long-term habitation. Moreover, as technology develops, we've begun thinking about how to terraform planets to make them more suitable for human habitation. For example, terraforming Mars by altering its atmosphere and temperature to create a livable environment. These plans may seem far off, but they are steadily becoming reality.
Speaking of which, I'm really curious, how much does the sun actually affect our lives? Besides providing light and heat, what else does it do?
The sun is undoubtedly the source and driving force behind all life on Earth. Its light and heat shape Earth's pleasant climate, allowing life to develop and thrive. Most fundamentally, sunlight provides plants with the essential energy needed to drive the miraculous process of photosynthesis. Through photosynthesis, plants convert carbon dioxide and water into oxygen and nutrients, not only purifying the air, but also supplying the basic energy for the entire ecosystem. These nutrients become the foundation for plant growth, and animals obtain the energy they need by consuming plants. Herbivores eat plants, carnivores eat herbivores, forming a complex and interconnected food chain. Humans, as part of this ecosystem, rely on both plants and animals to obtain the nutrients necessary for survival through our diet. The sun is not only the starting point for photosynthesis, but also the main driver of the water cycle and climate changes. It causes water to evaporate, forming clouds that bring rain to nourish all living things on land. It regulates temperature, keeping Earth warm enough to support life. Without the sun's continuous shining, Earth would become a cold, lifeless planet where life could not exist.
So the sun is basically the head chef of Earth's food chain.
The sun is not only the source of energy for life, but also profoundly influences our biological rhythms and daily lives. Every day, when sunlight shines down on the Earth, our bodies begin to respond to these signals from the sun, regulating our internal biological clocks to ensure we're awake and resting at the right times. One of the most important players here is melatonin, a hormone responsible for controlling our sleep. During the day, bright sunlight suppresses melatonin production, making us feel alert and energetic. The blue light component in sunlight is especially effective at telling our brain that it's time to be active, helping us stay focused and attentive. As the sun sets and the light dims, melatonin secretion begins, acting like a gentle sleep messenger that makes us gradually feel sleepy and prepares us for rest. This natural physiological rhythm creates our circadian rhythm, also known as the biological clock.
No wonder when I stay up late binge-watching shows, the next day's sunlight feels like torture. It's because my solar clock is all messed up.
Exactly. Long-term disruption of this natural rhythm can even affect mental health. The healthiest way is to simply live according to the sun.
So how does the sun affect weather and climate?
The sun is not only the source of life on Earth, but also the powerful engine driving our atmosphere and water cycles. It continuously delivers light and heat to the surface, creating the warm environment we need to survive. When sunlight shines on oceans, lakes, and rivers, water evaporates into vapor. This vapor rises into the sky, cools, condenses into clouds, and eventually returns to the surface as rain, snow, or fog, completing the endless water cycle. This sun-driven water cycle nourishes all living things on land and regulates climate and weather. Even more importantly, the sun heats the Earth unevenly. The equator absorbs more heat than the poles, creating temperature differences. These differences drive atmospheric circulation, which gives us the familiar seasonal changes and storm systems. Monsoons, typhoons, and heavy rains all originate from the sun's continuous thermal energy. Without the sun, Earth would lose all this energy. Temperatures would plummet, water would freeze, and the air would become dry and cold. The whole planet would become an icy, lifeless ball. It's because of the sun's constant burning that Earth can sustain the water cycle and atmospheric circulation, nurturing a vibrant and diverse ecosystem.
So the sun is like the main switch for Earth's air conditioning?
Exactly. With its endless energy, it controls Earth's temperature, climate, and weather, shaping every detail of our lives. During the day, The sun's rays spread across the land and oceans, warming them up, causing air temperature and pressure changes, driving winds and water evaporation, and awakening all life. At night, when the sun sets, the surface cools down gradually, bringing coolness and calm. It is this power of the sun that gives Earth its diverse climate zones, from the scorching tropics to the icy polar regions, creating rich ecosystems. It regulates the planet's atmospheric circulation systems, like the fans and temperature controls of an air conditioner, balancing temperature and humidity and maintaining climate stability. The sun heats the land and oceans, causing air movement that generates winds, which bring clouds, rain, and seasonal changes, keeping this Earth air conditioner constantly running. Even more importantly, the sun's energy drives the water cycle, the processes of evaporation, condensation, and precipitation, just like the circulation of cool air in an air conditioning system, continuously regulating the atmosphere's humidity and temperature. These seemingly natural phenomena are all results of the sun's heat energy control, constantly influencing our lives.
Hey, speaking of distance, how far is the sun from us exactly?
The sun is about 150 million kilometers away from Earth. This incredible distance has been defined by scientists as an important unit called the astronomical unit, AU. This unit serves as the basic standard for measuring distances within our solar system, giving us a clear and concrete scale to understand the vastness of the universe. Although light travels extremely fast, about 300,000 kilometers per second, meaning it can circle the Earth 7.5 times in 1 second, it still takes about 8 minutes and 20 seconds for sunlight to travel across that 150 million kilometers to reach our eyes. This time might sound short, but on a cosmic scale, it's an important delay, reminding us that the sun we see is actually how it looked 8 minutes ago.
So the sun we see is actually how it looked 8 minutes ago?
Exactly. Imagine if the sun suddenly vanished from the universe. What would that look like? Surprisingly, even if the sun went dark instantly, life on Earth would still enjoy its familiar light and warmth for about 8 minutes and 20 seconds. This is because although light travels incredibly fast, about 300,000 kilometers per second, it still takes light roughly 8 minutes and 20 seconds to cover the vast distance of 150 million kilometers from the sun to Earth. This time delay acts like a buffer, placing us at a fascinating boundary between space and time. When we look at the bright sunlight in the sky, we are actually seeing the sun as it was 8 minutes ago. This isn't just a quirk of physics. It's an awe-inspiring cosmic phenomenon. Only when that light finally disappears will the whole Earth plunge into unprecedented darkness and cold.
Wow, the sun sounds huge. Just how big is it exactly?
The sun is the giant of our solar system, with a diameter of about 1.39 million kilometers. That number is hard to imagine. It's about 109 times the diameter of Earth. If Earth were a tiny marble, then the sun would be a massive colossal sphere, stretching across the cosmic stage, shining and warming our home. Even more astonishing, the sun's volume could fit around 1.3 million Earths inside it. This immense scale is almost beyond comprehension. Just imagine how spectacular it would be to fit that many Earths inside the sun. In terms of mass, the sun is about 330,000 times heavier than Earth, practically controlling the lifeblood of the entire solar system. In fact, the sun accounts for 99.86% of the total mass of the solar system. Nearly all of the weight is concentrated in this blazing fireball. It's this massive mass that generates the powerful gravity, causing the 8 planets, countless small bodies, and comets to gracefully orbit around it, maintaining the order and stability of the whole solar system.
Oh my goodness, that's just overwhelming.
In the solar system, the sun is undoubtedly the irreplaceable big boss, ruling the fate of the entire system. When we look up at the night sky and see the twinkling stars and planets, we often overlook the true protagonist, that scorching, massive, and energy-packed Sunday. The other planets play supporting roles under its shining light, each tracing their own paths and stories. But without the Sun, there would be no stage for this cosmic drama.
The Sun's mass accounts for 99.86% of the entire solar system, meaning it wields overwhelming gravity that firmly holds the 8 planets, asteroids, comets, and even dust in place. Its gravitational pull is like an invisible giant hand, controlling the orbits of these celestial bodies, preventing them from drifting apart and maintaining constant order.
In comparison, the other planets are like the younger siblings in the family. Each has its own unique traits: Mars with its reddish hue, Jupiter's massive storms, Saturn's beautiful rings. But in front of the Sun, they all seem small and humble. The Sun not only dominates everything with its vast size and mass, but also powers the whole system with stable, continuous nuclear fusion, providing the light and heat necessary for life.
How does the Sun rotate? Does it spin like the Earth?
The Sun, the star we gaze at every day, seems steady and shining, but it holds many fascinating secrets. Unlike Earth, which is a solid sphere, the Sun is a gigantic ball of hot gas, which leads to a unique rotation phenomenon called differential rotation. Solid planets generally rotate uniformly, with the entire sphere spinning together like a disk. But the Sun is different, since it's made up of charged gases and plasma without a fixed solid structure inside. Its rotation speed varies by latitude. The equator rotates the fastest, completing a full spin in about 25 days, while near the poles, it slows down noticeably, taking roughly 35 days to rotate once. This differential rotation is not only a physical characteristic, but also the root of the Sun's complex dynamics. Because the equator and poles rotate at different speeds, the Sun's internal magnetic fields get twisted and stretched, generating powerful magnetic energy. These magnetic changes directly cause solar flares and coronal mass ejections, phenomena we commonly refer to as solar storms.
Wow, so its different parts rotate at different speeds?
The Sun's differential rotation is not only a unique physical characteristic, but also profoundly influences the entire solar system's operation. Since the Sun's equatorial region completes one rotation about every 25 days, while the poles take about 35 days, this variation in rotational speed causes the Sun's internal magnetic fields to continuously twist and tangle, forming complex and intense magnetic structures. These twisted magnetic fields are the source of sunspots. Although sunspots appear dark, they are actually cooler regions on the Sun's surface where the magnetic field is especially strong, suppressing heat transfer and creating these dark patches. Sunspots are not only obvious signs of solar activity, but also precursors to upcoming solar flares. When the magnetic energy accumulates to a certain level, it can suddenly release, causing intense solar flare eruptions. Solar flares emit large amounts of light and heat and eject massive amounts of charged particles, creating powerful solar storms. These charged particles collide with Earth's magnetic field at high speeds, triggering geomagnetic storms that can severely disrupt satellite communications and power grids.
So, what exactly are sunspots and solar flares?
Those dark patches on the Sun's surface are what we call sunspots. They aren't truly black, but they appear darker because they're significantly cooler than the surrounding areas, about 3,000 degrees Celsius, compared to the surrounding regions that reach over 6,000 degrees. That contrast in temperature makes them look dim. What's even more astonishing is that some sunspots are larger than Earth itself, large enough to fit our entire planet inside, giving us an even deeper appreciation for the Sun's immense scale. Sunspots form because the magnetic field in those regions is unusually strong. These intense magnetic field lines block the flow of heat from the Sun's interior to its surface, causing a drop in temperature and resulting in the dark appearance. Sunspots aren't static. They move along the Sun's surface with its rotation and can grow or shrink depending on changes in magnetic activity. That's why they're key indicators of solar activity. Closely tied to sunspots are solar flares. When a magnetic field on the sun's surface undergoes a sudden, violent change, the accumulated magnetic energy is released in a powerful burst, like the sun unleashing a massive fireball attack. The energy from these flares is immense, equivalent to the explosion of hundreds of millions of nuclear bombs all at once. In an instant, the sun's surface lights up and a huge number of high-speed, charged particles are ejected into space.
Do these solar eruptions affect us?
Solar flares are like cosmic thunderclaps. When they erupt, they release an immense amount of energy in an instant, and the impact on Earth can be profound. This energy, carried by high-speed charged particles, rushes toward Earth and inevitably disrupts our daily lives when it collides with the planet's magnetic field. One of the most immediate effects is on our communication systems. Cell phone signals become unstable, radio transmissions get filled with static, and long-distance communication becomes increasingly difficult. Additionally, GPS systems can malfunction. Whether it's navigation tools or aviation operations, both rely heavily on accurate GPS signals. If these signals are disrupted, incorrect positioning could lead to serious safety concerns. Even more severe, intense solar flares can cause widespread power grid failures. High-latitude regions are particularly vulnerable, as solar-induced currents can surge through electrical systems, potentially leading to massive blackouts that affect millions of people and disrupt industries and daily life alike.
Wow, so auroras are actually a side effect of the sun?
The aurora is nature's most magnificent light and shadow spectacle, a brilliant product of the intricate dance between the solar wind and Earth's magnetic field. When the solar wind, a storm made up of high-speed charged particles, erupts from the sun, these particles act like invisible messengers, racing across the vast expanse of space toward our home, Earth. Surrounding our planet is a powerful magnetic field, an invisible shield that protects us from the direct impact of the solar wind, much like a cosmic force field guarding life on Earth. However, when these charged particles approach Earth, the magnetic field doesn't completely block them. Instead, it guides them along magnetic field lines toward the polar regions. There, the particles collide at high speeds with oxygen and nitrogen molecules in the upper atmosphere, exciting those molecules and causing them to emit brilliant light. Waves of green, red, and purple light ripple across the night sky, dancing like vivid brushstrokes painted by a cosmic artist, captivating, ethereal, and impossible to look away from.
It sounds like the sun is truly mysterious. But what about its future fate?
When the sun eventually exhausts the hydrogen in its core, a cosmic transformation is about to unfold. The star we know so well will no longer remain stable. Instead, it will begin to expand, transforming into a massive red giant. As it grows dramatically, the sun's outer layers will gradually engulf the inner planets. Mercury, Venus, and even Earth won't be spared and will be consumed by the swelling red giant. Though this process may seem harsh, it's a natural phase in a star's life cycle. The expansion into a red giant occurs when the core runs out of fuel, triggering complex physical changes. Helium starts fusing into heavier elements, while pressure imbalance causes the outer layers to spread outward. Eventually, the sun will shed those massive, unstable outer layers, forming a beautiful and vast planetary nebula whose colorful gases drift gently through space like cosmic fireworks. Meanwhile, the sun's core will contract under gravity to become a white dwarf. Though small in size, the white dwarf will be extremely dense, a tiny, radiant gem in the cosmos. It won't sustain nuclear fusion anymore, but will slowly emit light using the heat it has accumulated, gradually cooling over eons until it becomes a black dwarf, a cold, dim remnant of a long-lived star.
That's so romantic. I never knew the sun's farewell could be so poetic.
In the vast expanse of the Milky Way, the sun is merely an ordinary star, not the largest blue giant, nor the longest-living red dwarf. It doesn't shine the brightest, nor does it boast the most majestic appearance. Yet, it is precisely this ordinariness that makes the sun a symbol of warmth and stability in the cosmos, a truly unique source of life for our planet. The sun's presence brings constant light and warmth to Earth, creating an environment suitable for life to thrive. Its steady energy output drives the water cycle and climate patterns, powers photosynthesis in plants, and supports the functioning of the entire ecosystem. Without the sun, Earth would instantly become a cold and barren wasteland, unable to sustain any form of life. From our perspective, the sun is more than just a burning ball of gas. It is a silent guardian. Quietly, it supports us, enabling us to breathe, grow, and flourish. Whether it's the gentle glow of dawn or the radiant hues of sunset, the sun is always there, accompanying us through every moment of life, an irreplaceable presence in our world.
After everything we've talked about today, I really feel like the sun is a warm and powerful guardian, not just a bright spot in the sky, but the most important pillar of life.
Exactly. Understanding the sun means understanding our connection to the universe and to ourselves.
Alright, if today's solar facts blew your mind, don't forget to like, subscribe, and hit that little bell icon.
And don't forget to leave a comment below. What do you think is the coolest secret about the sun? See you next time. Bye-bye.